Let's have a look at question 2 in this video. So we are a tennis player and we can choose between playing in singles or in doubles. Now if we're playing singles, our utility is equal to 100 with certainty. If we play in doubles, then our utility depends on the partner that we're gonna play with, and our partner has a skill, and that skill, that quality of the partner gives us a utility distributed on 70 to 120. Now each round of search costs us 4 units of utility. We have no budget constraints. Let's compute in question 1 whether we're gonna play the doubles or the singles. So to calculate this, we want to compare expected utilities. We have to compare expected utilities from playing a single and expected utility from playing the double. And when we talk about expectations, we deal with probabilities. So here we have the probability of playing single times the utility of playing single, and here we'll also have the probability from playing double times the utility from playing double. Now we know that is given in the question that the expected utility in the case of singles is equal to 100 units. So that's the probability 1, because it's with certainty, the utility is 100. So here we would have 100 units of utility. Now to decide what's gonna be the expected utility of playing a double, we must first see if it's worth for us searching for a better player, and if it's worth for us searching for a better player, then how much should we search? What is the quality of the player that we're gonna accept? So first things first, let's see if it's worth for us searching. We know that the player has a skill, a quality level between 70 to 120. And this quality determines our utility. So our utility depends on that. Now, when we start searching, just the first decision, we know that we expect an average between these two. This is our best guess, and the best guess is always the average. In this case, the median, the middle point. So the median between these two is going to be equal to 120 plus 70 divided by 2. Which is 190 divided by 2, that's equal to 95. So in expectation, we think that we might find a player with a quality level of 95. And recall that that determines our utility. So the expected utility from searching is equal to, just from searching, just if we search, is equal to 95. And the cost of that search, the cost of the first search, costs us 4 units of utility. So the cost equals to 4. Clearly 95 is much higher than 4, so for us it's worth looking for a better player. Now the question is, how long shall we look for a better player? How much can we gain from looking for a better player? Well, let's see. We know that the player will have this skill between 70 to 120. Let's draw it on a new graph. 70 to 120. And let's say that at the moment we found a certain player with a certain level, let's call that X. He has a skill level of X. Well, in expectation, if we consider to keep searching or not, we would like to have someone with a better skill. So we're interested in this area over here. That level of skill would be attractive to us. And for us, it must be worth it. So the expected benefit from looking for someone must compensate our cost. So the expected benefit of finding someone with a higher skill, so the level that we're going to find must be greater than what we currently have, must compensate our cost of 4 units of utility. And we're dealing here with units of utility. Okay, so how can we find this expected benefit? Recall, because it's expectation, it means it's uncertain, so we have to know the probability of this outcome times the benefit of the specific outcome. So first things first, what is the probability? The probability is the same as proportion. So in our case, we're dealing with a ratio of this area, 120 minus x, this length, relative to the entire length over here, which is 120 minus 70, divided by 120 minus 70. And that would equal to 120 minus x, 120 minus x divided by 50. That would be the probability of finding a better player. Now what would be the benefit? The benefit would be the fact that we have a higher quality player. So we expect to find a player with the median quality between these two. Why is that? Because that's our best guess. If at the moment our player has the quality of X, in expectation the best guess is that we're gonna have an average player between 120 and the current level. So that would be 120 plus X divided by 2. That would be the median in this area. So the expected value of the player, the expected value of that better player, let's call it X star, that would be greater than what we currently have, is equal to the median, 120 plus X divided by 2. But we're interested in the actual benefit, and the benefit means the improvement relative to what we have at the moment. So the improvement to what we have at the moment would be the quality of the player that we might get relative to the quality of the player that we currently have. So that would be this one relative to minus our current quality, minus X. And that would be equal to, this whole thing would equal to our expected benefit, expected gain by finding a better player relative to the current player. And now let's solve the math. Let's actually calculate the expected benefit by taking all these things into account. So let's do it over here. We take the probability into account and the benefit into account, such that the expected benefit would equal to the probability times the benefit. So that would be equal to expected benefit probability 120 minus X divided by 50. That would be the probability, and the benefit, we said it would be the difference between the expected value 120 plus X over 2 minus the current value of the player, minus X. So we have to solve this. Now what do we have in the second part? We have a fraction, a subtraction, but we don't have the same denominator, so we're gonna make the same denominator by multiplying this one by 2, such that the expected benefit would equal to 120 minus X divided by 50 times 120 plus X divided by 2 minus, here we have 2X divided by 2. So let's group the second part together. We would have over here, we would have 120 minus X divided by 50 times 120 plus X minus 2X. That's 120 minus X divided by 2. What do we see? We see that we have a multiplication, same numerator, so we can write it to the power of 2. It means we're going to have 120 minus X to the power of 2 divided by the denominators we multiply. 50 times 2, that's just 100. This is just our expected benefit, but recall that we must have the relationship with the costs. This has to offset our costs. So let's find that relationship. It means that expected benefit would equal to our cost of search, 120 minus X to the power of 2 divided by 100 must equal to 4, because that's the cost of search, 4 units of utility. We're calculating in terms of units of utility. Now let's do a cross product here. We would have 120 minus X to the power of 2 equals to 400. If we take the square root of both sides, here and here, we would have 120 minus X equals to 20, such that X would be equal to 100. And what does this mean? If X is equal to 100, it means that's the highest quality of the player we can find. That's when we stop searching. That's when we completely offset our cost of search. So if we get a player with a quality of 100 and this gives us our utility, or let's say the expected utility from finding a player and playing the doubles with him, which is also 100 units, because remember, our utility depends on the quality of the player. And we know from the question that the expected utility from playing the singles is also 100 units of utility. By looking at these two, we can say that we are indifferent. We are indifferent between them because we have no specific reason to go for one or the other. So we are indifferent. And that's it. We could go for the single, we could go for the double. In the next video, we're going to solve the second question.